Hi. So welcome to lesson number 1, module 4 of the Big Data Hadoop Developer course. So in this particular lesson, we will be introducing the concept of MapReduce. Now before we proceed with the lesson, since this is the first lesson of the module, let's have a quick recap of the previous module. So in the previous module, we learned entire HDFS architecture, such as what exactly is a name node, a data node, and a secondary name node, and what are the functions of these particular daemons, key concepts of the Hadoop distributed file system in depth, such as rack awareness, balancer, file storage process, read and write anatomy, difference between Hadoop version 1 and Hadoop version 2 in terms of HDFS, high availability, federation, and some of the key commands. In this particular lesson, we'll be understanding the concept of a MapReduce, and we will also have a look at a step-by-step execution flow of the same. Now, what exactly is MapReduce? Well, MapReduce is a software framework or a simple programming model based on Java language. Now, when we have our Hadoop cluster, we understand the data is divided into blocks and stored in multiple data nodes. Now, this is distributed storage. Now, in that manner, if we think about the data is no longer residing on a single machine. The data is actually broken down into pieces and it is residing on multiple machines. Now, MapReduce is a framework which allows us to write the program to analyze this data so that it can execute our program in a distributed cluster. So it allows us to process huge amount of data in parallel on large clusters. So the advantage of MapReduce is that the data is not getting processed in a sequential manner. Rather, once you write a MapReduce program, it will access the data at the same time parallelly and get it processed. Now, this is completely different from the traditional processing standards. Now, if you write a traditional Java or a .NET C# program, usually the concept is that the data will be presented to the program. That means your program sits in one place and the data comes to the program. However, in MapReduce, the data will not come to you, but the program goes towards the data. Now, why is it so? Because we are dealing with huge amount of data. We are talking about terabytes and petabytes of data, and assembling them in one place is a Herculean task. So that is practically impossible. Storing the data itself is a challenge. So getting the data by combining all the blocks and making it available at one place is simply a waste of time. So MapReduce takes a revolutionary approach by sending the program to the data wherever you have the data and to get the processing done. Now, the advantage of MapReduce is that you can write a MapReduce program usually in Java. However, it can also be written in many other popular programming languages such as C, C++, Python, or Ruby. Now, the data processing is done in a reliable and fault-tolerant manner while running on commodity servers. Now, let's go ahead and explore this further. Now, what are some of the advantages of using a MapReduce program? The first thing is simplicity, which means to analyze the so-called big data, you don't have to really learn a new programming language. You can write the logic in whichever language you know, such as Java or C++ or Python, and the execution part will be entirely taken care by the MapReduce framework. So the first advantage that we have is simplicity. Now, the second advantage is scalability. Since we have our Hadoop cluster already present, there is no question as to how much scalable a Hadoop cluster can go. We can literally have tens and thousands of nodes in a Hadoop cluster, and the processing can happen parallelly. Now, the third advantage is fault tolerance. Now, we know that there is a built-in replication which is happening inside HDFS. So that means the blocks which are part of our data is going to be present in 3 separate data nodes. So having a data node which is not functioning or a data node going down is really not going to have any impact on our processing, because MapReduce can find the next available replica and start processing from there. Now the fourth one is speed. Now any traditional programming technique usually analyzes the data in a sequential fashion, but MapReduce does it in the parallel fashion so that the processing is really fast. Now last but not least, the advantage is data movement. As the processing happens at the nodes where the data is stored, there is minimal movement of data blocks. So just like I have explained before, taking all the blocks from different data nodes and combining them and sending them through the network bandwidth that we have is not at all cost effective and practical. But however, to help us, MapReduce will send the program to the data so that we are really saving the network bandwidth and adding a plus on the performance side. Now let's understand in a bit more detailed manner how exactly MapReduce works. Now the MapReduce programming takes a radical approach at data analysis. So usually imagine that you have a huge pile of data and you want to extract some useful information out of the data. And that's exactly data analysis. Usually you will write a code which can go through the data line by line or maybe word by word and extract the interesting word or maybe the phrase and store it in some sort of an array, or then increment a particular counter or something like that. Well, this approach is not good if you have a huge amount of data and as well as when the data is not in one place. So in a cluster where the data computation processing is taken to nodes where the data resides, that situation is called data locality principle. So rather than depending on a sequential program execution, MapReduce breaks down the entire analysis into 4 major phases. Now, the first phase is called an input split phase. Well, I'm not going to explain the input split phase here, but we will have a look at it in a detailed manner. The second phase is called the mapping phase. So the idea behind a MapReduce program is that you are supposed to write 2 separate programs. One program is called your mapper program. The other program is called your reducer program. So the name MapReduce came because it is a result of a mapper and a reducer program. Now, why do we really need the mapper program? Now, imagine that you got a huge set of data, maybe a financial data from a bank, and you are looking for a particular branch code, let's say B1, and you would like to find out how many times that branch code has repeated. So the first phase, or in the mapping phase, what usually happens is that you should write your logic in such a way that you can extract the useful information from the given data set in the form of key value pair. Now MapReduce works on the principle of key value pairs. Everything in MapReduce has to be expressed as a key and a value. So in the mapping phase, or to be precise, your mapper program will run wherever your data resides. Maybe your data is broken into 10 blocks and they are in 10 data nodes. So the mapper program runs on 10 data nodes and it simultaneously extracts whatever information you are looking for in the form of a key and a value. So in our example, we are looking for a particular branch code, let's say BR1. So maybe our mapper program will analyze the huge data which is present in different nodes and extract the branch code as the key and the value as the number 1, because for every occurrence of a branch code, it will read the branch code as a key and the value as 1 because it is a single occurrence. So as you can see in the mapping phase, basically we are extracting useful information and representing that in the form of a key and value. Now the next phase is called shuffle and sort phase. Now during the shuffle and sort phase, the framework will collate all the values of a particular key together at one place. Now when we run the mapping phase or the mapper phase, let's say we have 10 data nodes. In every data node, your BR1, the branch code 1 will be there and a value 1 will be there. So BR1, 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 that will be on data node 1. Again BR1, 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 that's on data node 2. So in the shuffling and sort phase, what happens is that the framework will pick your key, which is BR1 in this case, and it will pick all the values from different data nodes and collate and give it at one place. So at the end of the shuffle and sort phase, your data will look like this. For example, BR1 as your key, and in the value you will have like 1, 1, 1, how many times it has repeated. Now last but not least, you have the reduce phase. So in the reduce phase, you can write a simple logic to aggregate the values that you have collected. So in this case, since you want to count the number of occurrences, maybe in the reduce phase, you can write a simple Java logic which will count all the values. So at the end of the reduce phase, you have your final answer. Now this is a pictorial representation of the same concept that we have discussed. So as you can see in the mapping phase, the program runs on every data node wherever you have the data. In shuffle and sort phase, the individual entries are extracted and the values are added. And in the reduce phase, you do aggregation. So mapping is a phase of segregation, whereas reduce is a phase of aggregation. Now let's try to understand this particular concept with an example. Now as you can see from this particular picture, we have an input data set which is a set of words like book, pen, pencil, eraser, etc. Now we would like to do something called a word count program on this. The idea behind this is to count the occurrence of every word and sum it up. For example, the particular word called book has repeated 2 times in the data set. So we should ideally get a result as book, 2. And much the same way, the word pen has repeated 3 times. So we should get a result pen, 3. Now let's see what are the different phases in this particular example. Now as I have explained before, the first phase is splitting, second is mapping, then shuffling, and last reducing. Now let's explore this step by step. So the first phase is called splitting phase. Now ideally your data will be divided and stored in different data nodes. Now in this case you can see that every line of my input file has been stored in a different data node. Now in the input split phase, the MapReduce framework will decide how your data is divided and where it is located. Based on that, the framework will decide as to how many copies of the mapper program should be sent to those data nodes where those blocks are present. So as you can see from this particular picture, we have our data which is divided into 3. So that means 3 copies of the mapper program need to be sent to 3 different data nodes. Now once the input split phase is over, the next phase is the mapping phase. Now the idea is to figure out the number of occurrence of each word. So what we can do is we can write a simple Java mapper program in which it can read an entire line, and maybe using space as a delimiter, it can tokenize every word. Technically speaking, it can extract every word from a line and that word will become the key. Now the value will be a hard-coded one. So as you can see, Once my mapping phase is over on every data node, now I have the data in the form of the name and the value format. For example, in data node 1, I have book, 1, pen, 1, and pencil, 1. Map script basically extract this information on every data node. Now the next phase is the shuffling phase. As you can see, if you look at a particular key here, let's take an example of the key called book. Now the book is there on data node 1. However, it is also there on data node 3. Now in the shuffling phase, you can see that the book, 1, book, 1 from data node 1 and data node 3 have been assembled at one place. Much the same way, the three values of pen, 1, pen, 1, pen, 1 from three different data nodes have been assembled in one place. So the shuffling phase basically combines all the keys, all the values of a particular key from different data nodes and make it available at one particular place. Last but not least, we have the reducer program. So in the reducer program, again, we are writing a simple Java logic which will sum all the values of a given key. So the input to your reducer program is the shuffling output. So if you look at the first key of the shuffling phase, you have book, 1, book, 1. Now in the reducer, I will write a Java code which will basically add the two values of the key called book. So 1 plus 1 equals 2. So I get a final result as book, 2. Much the same way, I get pen, 3, pencil, 2, eraser, 2, giving my final result with the number of occurrence of each word. So to summarize, in this particular lesson, we have learned the concept of MapReduce and also analyzed the step-by-step MapReduce execution flow. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.